Hello, good morning and good afternoon. I hope you guys can hear me okay. Excellent. Well, welcome to another Bespoken webinar. I've lost track at this point about how many we've done. I think this is maybe our 8th. But we're really glad that you could join us. We're going to cover some slightly different material than we normally go through. Try to give you an overview of our toolkit, sort of more broadly, and then also really talk about what we consider to be general development best practices for Alexa skills. So we're excited to go through this content. Just some general housekeeping items. One, we do record these webinars, and we make the recordings available to you after they're done. Additionally, the slides that we go through, we'll send those along as well. So as I'm going through stuff, we've got a few slides. You don't need to frantically take screen caps or anything like that. We're going to include all that for you afterwards, even if you don't attend. So if you're not here, if you're watching this on a replay at a later point, we're going to send this information to you. And additionally, we have these chat tabs and questions, and you can ask me questions as we're going through it. It's a little tricky doing the interactivity with these webinars, but what I do is I keep my Slack open on my phone, and Yvonne and some of the other Bespoken folks, they'll forward me the questions as I'm going through. And so I try to keep an eye on that and respond as I go along. We do try to make this interactive just so that we're clearly explaining things, and that you folks that are attending are getting the most out of it. Lastly, I'll just mention that we have a poll section with some questions for you guys. If you can answer what we have in there, it's really helpful information and feedback for us, both around improving these webinars as well as what we're doing with our product. All right, so with that, I am going to go ahead and share some slides with you, and then we're going to go through some pretty cool demos. All right, so introductions. I'm John Kelvey. Yvonne Perez from our customer success team is on this, and I believe Farella Casavilca is as well. They're in the chat window there, and you can talk to them. About us, we provide monitoring and testing tools for voice apps. We're a recognized vendor of Amazon and Google. We have over 1,000 apps that we're monitoring. We have more than 3,000 developers using our tools. We have a command line tool that's very popular. We actually don't have exact numbers on that one because of the nature of it. I think it might be as many as 4,000 overall that are using it. And then we also have a long history with speech recognition and AI. I, prior to founding Bespoken, was actually building really robust high-scale speech recognition system. The experience around doing that, that really informs our product, and it's part of the reason why we got so excited about this space is we saw Alexa and Google Assistant coming in, just really changing what people were doing with AI in a way that we thought was just terrific. But we also saw a need for new development tools and testing tools, and that was the genesis of our company. So I do want to give you a quick overview on testing and monitoring. Before we go into the demos, just to kind of ground you in how we approach things and what we think is really important here. And so we have this layer cake that you'll see on the right-hand side. This really describes what we see are key aspects for testing voice applications. And so those are at the top, we have manual testing. And that is something I think almost everybody does today. And that's really about just doing ad hoc testing to make sure that your skill is working correctly. You can really go quite far with this. Manual testing can take the form of functional testing. It can be exploratory testing. It can be crowdsourced testing. Depending on the importance of your skill, there's really a lot to be done there. It's not our focus, though we do have some manual testing tools to help you as you're doing your development. But really where we come into play as Bespoken is on that second layer, automated unit testing. This is really about ensuring that your code is working correctly. During development time, it's extremely helpful for developers as they're building their skill to check and make sure that, to add unit tests to make sure that the code is doing what they're expecting it to be doing. It's the way that we built our automated unit testing offering. It can all run locally. So in taking advantage of that, you're able to build things in a higher quality way. And then also by building things and testing them locally, just right on your laptop, you're able to do things much faster. And that's true of our manual testing as well. So when you think about automated unit testing, don't just think about it as something that's quality. I mean, that's quality is the part that everybody agrees is important, but they don't necessarily get excited about. It's also going to make you go faster, and it's going to accelerate your time to market for building skills. And so that's kind of the sweet part that I think it's, if you're a developer, that's an easier thing to get excited about a lot of times. But then the next layer here, the end-to-end testing, this is sort of the other side of the coin to the unit testing, where instead of focusing on making sure code is working correctly, still part of it, but the focus is on making sure the system as a whole is working correctly, and in particular, that the speech recognition and the AI concerns are working correctly. And so it's about testing a skill from start to finish and testing it through the actual Alexa, simulating an actual user interacting with it. Then the last layer here, the continuous testing, this is really about, on an ongoing basis, making sure that the skill is functioning correctly. We also refer to this as monitoring, but the reason why we use the label continuous testing is just to emphasize we're using the same techniques that we use with the end-to-end testing, but then we're actually running it on a 30-minute basis. So with your end-to-end test, you might have hundreds, if not thousands, of test cases. For your continuous testing, you're going to down select to really just a few of those test cases, run them regularly, make sure everything's working right. If there's any problems anywhere in the system, the continuous testing is going to be very effective at detecting those. So the manual testing, like I said, we offer some command line tools. Their main advantage and why you'd want to kind of take a look at these is you can actually run them just locally. So most of the manual testing tools that you have out there, they're going to require that you actually have deployed your skill, that you've deployed the code out there, that you've updated your interaction model. That's fine. That's actually an important thing to do, to actually deploy it and test it. But if you leverage our ad hoc tools here, you can actually test it without having done all that deployment. For some types of manual tests, that's a very useful thing, and that can accelerate your development. Those deployments, I think, as anybody who's done it knows, they're going to be quite slow. They're a little bit error prone. If you forget to save a file before starting the deployment and you have to go back and do it again, that's kind of a painful process. So there's some nice advantages to being able to do it locally. The unit testing, which we're going to go into more depth on with our demonstrations today, the unit testing, though, is really about creating tests that can be run in an automated fashion, making sure the code is working right. It's what we do with this is we actually emulate the behavior of Alexa or Google Assistant that we support also. And with those platforms, we're generating JSON as if it's coming from them, but it's not actually coming from them. It's just coming from our library locally, which is how we're able to do it all locally. And besides some of the other benefits I mentioned with the unit testing, that it's going to allow you to build things in a higher quality fashion, it's going to allow you to build things faster. Another nice thing with it is it allows you to hook into sort of the rich ecosystem that's available today, typically through GitHub. And if you have some unit tests and you're working with GitHub, you can easily take advantage of code coverage tools like codecov.io. I have a picture of that here. That's going to show you nice graphs on your progress over time of your quality. It's going to show you, you can dig through and see what's happening with your code. Really a lot of nice stuff there. And then you can also hook into continuous integration tools. Really not too hard to do, so that every time that you push code to GitHub, it automatically runs these unit tests. Essentially, you put this little bit of investment in as a developer to writing your unit tests, and then there's all these nice benefits that accrue to you. That's how we see it. It's a small investment that pays back in many different ways, which we think is really cool. And it's also something that we would say Amazon agrees with us about this, and they've actually started incorporating our unit testing tools into their samples and tutorials. And so you can check out one here. We're going to go through another project that we've been working with them on. It's very helpful stuff, and it's moving towards sort of best practices for development. That's what we're sort of encouraging, and also what we're talking about today. So then end-to-end testing, as I mentioned, this is the other side of it. With the end-to-end testing, what we actually do is you type out the tests, what you want to say, what you expect back in reply. And what we're going to do is we're going to take those what you want to say pieces, that text, we're going to turn into speech. We're going to send it to Alexa. It's going to go to your skill. Your skill is going to come back with a reply. You're going to turn that reply, which is audio and JSON, but the audio part, we're going to turn that back into text, and we're going to compare it to an expected result. That's a lot that's happening behind the scenes, but at the end of the day, it's a very easy way to construct tests. You're just typing out, here's what to say, here's what I expect it to say back. So we try to make it very easy to create these tests that then do this sort of very complex simulation about the user behavior. And so then just a couple considerations we'd like you to keep in mind before we get into some of the demos. When you're thinking about AI and building for it and testing for it, it's that with AI-based systems, you have this sort of constant evolution. Actually, in the project that I'm going to show you here, I think probably one of those cases is illustrated in that a test case that we had that uses the dialogue interface, which was initially working, actually stopped working. And that has something to do with the platform there, but by having automated end-to-end tests, we're actually able to detect that. And there's not really an easy alternative other than having automated tests for finding that. Even the unit test won't protect you from that because it has to do with the behavior of Alexa and the dialogue manager inside of there. You have similar types of things that can crop up with the speech recognition, with the NLU. These things are based on machine learning. They're changing over time. And that change, even though it's definitely meant to be for the better, and it typically is, it may not be for the better for your skill because it's going to change, it gives you a different response. And that variability can lead to difficulties and lead to bugs. Additionally, languages and locales. Obviously, language and internationalization has always been difficult for app developers, but when your voice is the primary input, it becomes that much more challenging. And if you do a bad job with internationalization, maybe in the past it's just sort of a usability issue, But now what we would argue is that it goes beyond usability because, for example, if you take someone who's not a native English speaker, but speaks with a Spanish accent or a Chinese accent, if the device does not understand them correctly and it just says, sorry, I don't know what to do with that, the difference between that and an API failing, the system not responding at all, I mean, to the user, it's going to feel like an utter failure. And it goes from being like a button that's mislabeled that, the user can still kind of figure out, they get sort of what you're trying to say, even if it's not the way that they would say it, to a situation in which it's just not working at all. And so the impact of issues with language and locales, with idioms and accents, those issues become very profound. And it becomes very important to address them. And the best way to address them is through testing and then actually trying to fix those issues through your interaction model. And then lastly, platform behavior. There are different platforms that are out there. Obviously, Alexa and Google are very popular. There are other ones that are on the way. You want to have a consistent experience across these platforms. And again, testing is a great way to ensure that consistency. Okay, so with that, I want to jump into doing our demonstrations here. And what's a little bit different today than what we normally do is we're actually going to be showing you all this work in VS Code. And so in general, there's a toolkit that we think is, should be part of a standard toolkit for any developer. And that's using the Ask CLI, it's using VS Code, and it's using our Bespoken CLI. Those three pieces together, we think are just a great toolkit for any developer. Now, we're not going to go through today how to set up VS Code or Ask CLI. It's pretty easy to find the instructions for setting up Ask CLI. I brought up this website. If you also just type into Google VS Code, you'll see how to set that up as well. It's straightforward to get these pieces set up. And once you do, we can actually go ahead and start using our sample project here. So the sample project we're going to go through is one called College Finder. We've actually been working with the Amazon team to add unit tests and end-to-end tests, as well as continuous integration to this project. We think it's a pretty cool project, and it's a more complex and rich experience than I would say is typical for a lot of the samples that are out there. I think if you've spent much time doing skill building, this sort of behavior that you see here, the richness of the behavior, as well as the complexity of the code, is probably more in line with what skill builders are used to dealing with. What this skill actually does is it allows you to search for colleges that meet criteria that you specify. And so you as a user have an ability to put in a profile about yourself, what your prospective major is, what your budget is, what regions you're looking to potentially attend school in. You can provide all that information, and then this skill will actually go ahead and search for colleges that match those criteria. And it does the search using an API. This is an open one from api.data.gov. And so it has this external integration based on the profile data that you fill in. And it makes use of The dialog interface, it makes use of DynamoDB. So when you're providing information about yourself, it actually stores that. It has display templates built in, so it's actually meant to work with the Echo Show as well. There's a lot that goes into this, and it's not a simple skill. I would say that this goes to the idea that, we're talking about industrial grade skill building. So this goes beyond like, okay, I've built a get fact skill. This is, moving more into sort of, let's say, the professional territory. And so the complexity goes up, and the need for having really great tooling also goes up as well. I'm just checking here on Slack to see if I have, okay, good. Just making sure there's no questions there. So this is a nice skill. In order to get started with it, oops. We go here and I clone the skill. I'm actually cloning my version of it, which is where I've added the tests. This is also just generally available on the Alexa site. But so you go and you say git clone. And so I already did clone this, so it's already there. But if you haven't done it yet, that's how you actually get access to this. And then I'm going to open this in VS Code. If I hadn't done that already, I'd go ahead and say open folder. Go and select my folder and open it up. And then at this point, I have my skill. And if we look at this top directory here, we see that we have some information for Ask and GitHub and VS Code. That's sort of all just configuration stuff. But then the core artifacts are Lambda, models, and test. And so Lambda's where our code is. We'll go into that in a moment. Models are where all the interaction models are. And then test is where we keep our end-to-end tests and unit tests. And so we do have both within this project. With the code here, if we just take a look, we can start with the index file. So the index is actually not really doing very much. Instead, what it's doing is it's actually registering all the different handlers. And we have basically handlers for each of the major sort of, let's say, intent groups. And so we have handlers for intents related to the profile and the user specifying their criteria. We have handlers for basic search, handlers for a deeper, more refined search, handlers for managing the results that come back. Because you may have many colleges that meet your criteria, there's an ability to scroll through that information, both verbally as well as if you have a display, you can use the touch interface there. So really here what we're doing is we're just setting up our different pieces of code. And since we have this code all set up, the first thing that we'd like to do to actually start interacting with it is we're going to run just a simple unit test. So if we go to test unit, we see some unit tests here. These are for our basic search. And so the basic search is not doing search based on criteria we specify about core profile information, but instead it's just, hey, tell me about schools in Maryland, for example. That's this intent here. Or tell me about a school with this name. Or tell me about schools with this major. So it's kind of a shallow search. One additional thing that we're testing here is this is using the can fulfill intent request. Not going to spend a lot of time on this, but it's sort of an interesting feature. For those of you that are not familiar with it, the idea by using this is you can register your intent as sort of a top level intent. So the idea is that for the intent search for school by location, rather than just Alexa giving back the information that it has, instead it could use your skill even though the user doesn't even ask for it, which is really a neat aspect of Alexa. It's a pretty new thing. So basically, you can make the intents for your skill top level intents, so people don't even have to know about your skill or ask for it in order to start using it. It's kind of an amazing thing. So we have these basic intents that we set up. The way the test is structured, we have the intent name, and then we have the slot values, and then we have tests against what the response is. And here we are using the intent names. You can also use utterances, but it does work better generally for the unit tests to just use the intent names. So let's go ahead and run our unit tests. So to do that, we're just going to run this one particular file. And so we say bst test unit basic. And now this is just generating JSON requests locally. It's not actually interacting through Alexa. It's just running right here on our machine. So it really runs a lot faster than if we were interacting with Alexa directly. Now our test ran, and what we see here, oh, run this again. I'd accidentally down selected my test. Yvonne is telling me I should make my screen bigger, so I'm just going to try to make the font a bit bigger here. We'll make this 20. All right, so that should be more readable, hopefully. And okay, so we ran our tests, and we see 4 of our tests passed, but 1 failed. And the one that failed is search by name intent. And here we're looking up by a school name. And we said, we expected it to come back and say University of Maryland College Park is a school in Adelphi, Maryland. And instead it says University of Maryland University College is a school in Adelphi, Maryland. So, okay, that's kind of perplexing because if we look at our test, our slot value for school name is University of Maryland College Park. So what happened? So this is a good transition from looking at unit tests to actually how we debug our skill and debug our skill using VS Code. And so as some background, to set up our debugger in VS Code, we create a configuration. And the configuration we tell it a program, and in this case we're telling it our bst test.js. So we go to the directory where our bespoken tools are installed. We would have already installed those by typing, it's all over our website, but in case you don't see it, bespoken tools-g, that's how you install it. So the directory that that's installed in, we then reference the bin bst test.js because that's what's actually going to run the test. And then we set up args. So when we're running it on the command line, we said unit basic here. Well, this is the argument. And so we pass it the same argument. And this is just saying when you run the tests, just run these specific tests. It's kind of helpful to down select to a particular one. And then lastly, we set an environment variable. This is actually a requirement to use the external API that we're leveraging here, the api.data.gov. It requires an API key. I already signed up for that. I got an API key, and then I set it as an environment variable like this. And so with that, we now have the ability to run tests within the VS Code environment and actually debug them. So if I go into our Lambda custom directory, I can set a breakpoint, and I'm going to set a first breakpoint here on my code. So I can just see, first it's sort of a sanity check. Let's see what the slot value is. And actually one other thing, I'm going to set this to be only. I can say test.only, so it only runs this test. That's a very helpful thing so that I'm not running 10 different tests, which makes it harder to debug and to step through and really figure out what's happening. So now that I've set my breakpoint, set that here. I can go ahead and say start debugging. And yeah, any moment now. And there we go. So we started running our test, and what we want to see is just confirm that the slot value at this step is really being set correctly. We have a ton of information here, all the different values of different variables. We added a watch, which allows us to keep an eye on one particular value. In this case, we added a watch on the school name slot value. And so we can confirm here that, in fact, the school name is set to University of Maryland, College Park. Now, we wouldn't expect it to be anything different, but it's always good to kind of do that sanity check and make sure things are what we think they are. Now, using a debugger is not the only way to get at this. You could also use console.log. We print out actually requests and responses automatically. You can get at that data also that way. The nice thing about using the debugger is you can ask all sorts of questions about the code very easily. I can look at any state of any variable. I can look at what's happening in the call stack. I might even find out that this code's not being executed, which by itself is sort of significant. So lots of different things that I can check. And in this case, I've added additional breakpoints to then see, okay, my slot value is set correctly. What's happening when I'm querying that API? And so here, we've actually started doing, this is just before we call the API with our search. And let's see that the name that it's looking for is right, because I do some manipulations on the slots. And it looks like that name is set correctly. Again, it's looking for University of Maryland, College Park. So now let's see what the API comes back with. So I called the API and very quickly came back with a response. And that's set as the school value. And I'm going to step over that. And I can look at the school. And there's a lot of data that comes back from this API. And I can see that even though I told the API I was interested in University of Maryland College Park, it came back with University of Maryland University College. So it appears that there's either something wrong with how I'm calling the API, or more likely, because I know in general I'm calling it correctly, it seems to work for other cases, the API itself is imperfect. Now it's outside the scope of this particular project to fix that API. If it was an API that I owned, maybe I'd report a bug to them. But now I've sort of ascertained what's happening with this quite easily. And if I want to fix my test, probably the most likely thing that I would do is I could change this to be University of Maryland University College as the expected result here. Or more likely I pick a different college to test with. I might set this to test.skip. So I have this test in there. I report a bug to the API people. I leave this in here as a skip test until they come back to me and say that it's fixed. And in the meantime, I write a unit test that tests the search for school name with a different college that does work. But so this is an example of a whole workflow that we would go through in terms of running unit tests, identifying an issue, working through fixing the issue, and updating the tests. It's a very, very helpful process. Once you have these pieces set up, it really goes quite quickly. And I see there's a question. I'm told there's a question. Let me look at that. If you want to specify more arguments, would you do it like unit basic, unit more complex, or something like that? Yes, you would. It's an array, and so you can specify as many arguments as you want to that array. That's how it works with VS Code. So it is like you're typing in the command line, but for VS Code, passing those arguments, it's done as an array as opposed to just space delimited. But pretty similar other than that. So we just covered unit testing and debugging. Now we're going to talk about end-to-end testing, as well as show you a little bit of our proxy tool. So we are covering quite a bit here. I will just mention, obviously, again, we'll have this replay available. Additionally, we have a lot of documentation around all this different stuff we're going through on our site. So we are going through a number of different things. If you have more questions, you can reach out to us. Also, look at our docs for more in-depth information. But so to show you what our end-to-end tests look like, it's pretty similar to what we've done with our unit tests. It uses the same, we have this YAML syntax. This is very easy to work with. You don't need to be a programmer to write these sorts of tests. One difference you'll see in these end-to-end tests versus the unit tests that we had is that the end-to-end tests, we're not specifying the names of intents, we're actually putting in the actual utterances. So the unit test, you can use the intent names or the utterance names or the utterances. End-to-end tests have to be the utterances because they are interacting with Alexa. So this is quite literally what's going to be said to Alexa. So if you give it an intent name, it's not going to understand that. And so we're working through a conversation with Alexa here in this test. And in this case, we open the skill. We say no because it asks us if we want to finish filling out a profile. We say search by major. We give it a major name. We ask about the results, and we ask about a particular part of the results. We're working through a whole conversation with the skill in doing this. So it's similar to the unit test in the structure, but what we're doing here is by interacting actually with Alexa, we're able to test aspects of the pronunciation because we can use different voices. We're able to test aspects around language because we're able to write these in different languages. We've actually successfully tested, I think, in pretty much every language that Google and Alexa support. And so, even though nobody on our team, for example, speaks Japanese, we're able to write end-to-end tests in Japanese, which is a really cool thing and really helpful for testing skills that work in different localities where you may not have people that are native speakers. And we're able to test things like the dialogue manager and make sure that that's performing correctly, in an automated way. So we're really looking at a different set of things with these end-to-end tests, but applying the same structure and format so that you have just you can do it in a consistent fashion. And I'm told there's another question. And somebody asked, I've seen other test examples on the Bespoken website that use a describe its structure in a JS file with virtual Alexa as opposed to a YAML test file with the BST command line. What is the difference between the approaches and which should we choose? Yeah, so I'm showing you this right now in our YAML structure. Everything that we're doing, there's libraries underneath it, and you can also use those libraries directly, and you can use it with test tools like Mocha and Kai or Jest, and write directly using those libraries. We encourage people to use the YAML structure. We think it's easier to work with. It's still quite powerful and flexible, so you can still write a little bit of code if you need to. We have some special features for doing manipulations. But it's the YAML is going to be easy to read, easy to create, and quite powerful. And so that's generally where we steer people. At the same time, we see folks with very complex test cases where it doesn't work well with the YAML. If you have lots of, if it replies with this, then go do this other thing, or check the reply against this external API, those sorts of requirements, then the YAML is not really a good fit. And in those cases, we advise people to use JavaScript or some other programming language to write their tests. Additionally, a big consideration is just what's the skill set of your team. If you're talking about unit tests, it's almost always a programmer that's writing those. So they're obviously going to be a good programmer, and whether to use YAML or use JavaScript, it doesn't really make that much difference. The programmer is going to do fine with either one. But if you have a testing team and the testing team does not have a programming background, that's where we think the YAML is particularly advantageous. We built that YAML syntax with non-programmers in mind. And so it's meant to open up the audience of people that can do these sorts of tests. We've been very successful at getting non-programmers using the YAML syntax. We're proud of that. We think it's a nice thing. And so if you have that sort of non-programming user, the YAML becomes particularly valuable, let's say. So the short answer is we generally advise people to use the YAML, but it depends on your skill set and your requirements. And in particular, if you have non-programmers, then it becomes almost essential that you use the YAML. And that is a really common question that we get. So thanks for asking that. But so looking back again at our YAML and our end-to-end test here, we set this up. I have this set to test.only because I'm just going to run this one test in this file to show you guys how the end-to-end testing works. And I'm going to combine this with our proxy. So what is the proxy? Typically, when we're running an end-to-end test, what we're going to have done is, I may have gone here and I would type ask deploy, and I push my code out to Alexa. And then I run my end-to-end test against that because I'm interfacing with Alexa, and in turn, Alexa talks to my skill. And so my skill needs to be available out as a Lambda or on some server somewhere. However, another tool that we have, which is really very popular, I typically don't spend a lot of time talking about it, but it's very popular and very useful, is our proxy. And our proxy, what it does is it actually creates a tunnel that allows Alexa to talk to my laptop. It's kind of an amazing thing. And so I can run end-to-end tests using Alexa that then in turn talk to my laptop. And so to run them, I say BST proxy, I'm running it as a Lambda, and I give it the path to my Lambda code. And when it starts running, it prints out this URL. Now, in preparation for running this, I actually configured this URL on my skill. So I set my HTTP endpoint to that URL that was printed out there. And so what that says is to Alexa, send those requests to my desktop. Now, I should mention, I'm trying to give you guys an overview of the different tools that we have. I don't typically run automated end-to-end tests using the proxy. I run ad hoc tests using the proxy. So what's the scenario? I'm playing around with the skill. I got my Alexa device right next to me, just added a new intent. I just want to see if it works right. You know, does Alexa understand it well? If it's an invocation name, does it seem to work well, or does it confuse it with another skill? It's just a nice way to get a read on how things are working. I think the proxy works better for that. For the end-to-end tests, and we may see this here, running a whole bunch of tests in sequence, you're more likely to get some network latency running things this way, some type of error. It's not the most reliable way to run an end-to-end test. But so I've kicked off the test. I can actually see the request coming to my laptop. That's kind of amazing, right? And I can also see the interactions happening in the console. So our end-to-end tests use virtual devices, what we call virtual devices, that work like a physical hardware device, except we can talk to them programmatically. But other than that, they really are, you know, to Alexa, they look just like a real device. And so if I look at my utterance history, I can see all the interactions happening here. And I can even go in, you guys won't be able to hear this, but I can go in and I can play back the audio. I can hear what the audio was that was generated by our software to speak to Alexa. It's a really cool thing. So these virtual devices, it really is simulating somebody interacting with Alexa. And now I look over here and I can see that I ran this end-to-end test. Everything passed. I ran just one test, but went through this whole series of interactions, and it all worked correctly. And that is really cool, right? And it actually ran with it directly on my laptop. Now, looks like it's running correctly. At this point, I may certainly do my ask deploy step. So since all these tests are passing, you know, I've got my unit test working, I've got my end-to-end test working. Now I want to do an ask deploy. And then what that's going to do is that's going to actually push out my code to my Lambda environment. It's also going to push out the new version of my interaction model. So that's a really handy command to know and take advantage of. You know, we don't recommend every time you make a code change doing a deployment. That sort of stuff you should be doing with unit tests and using VS Code and using your debugger to work through issues, to add different lines of code, make sure it's all working correctly. But once it is working correctly, then you do your deployment. And you can do it much faster by using ask deploy, which is a really helpful thing. So we've got 10 minutes left. I'm just going to try to show you quickly how we then tie this into a continuous integration tool. So in this case, we're using Travis. And what Travis is going to do, if you're not familiar with CI, is whenever I make changes in GitHub, it's going to go ahead and automatically do some stuff for me. And in this case, the stuff that it's going to do is it's going to run my unit tests and it's going to update my code coverage. That's my entire script that it's going to run. Now I also do some install, which is I install our tools. I install CodeCov. And CodeCov, that's just a tool that takes code coverage generated locally and sends it to the website. So really simple. So it's not hard to create this Travis file. In fact, it's very easy. You could just cut and paste this yourself if you use the same sort of unit testing structure that we use and run this. This will work. You know, this same type of file is what we use for a lot of our projects. And then whenever I make a change, I can go here and I can look. And I can look through my build history. And I've been making changes to this project, you know, it's over the last month. And I can just see what's happened every time that I've made changes, making sure that those are working correctly and all my tests are passing. And one really nice basic thing you get with using a tool like Travis and using continuous integration is, you know, a common issue people have is things work in their environment on their laptop, but they don't work for anybody else, or they don't work in production. Well, this is a clean environment that's doing the build, that's running the tests, and it will chase out a lot of issues you have that are, you know, works for me but doesn't work anywhere else. That's one nice benefit. Another nice benefit is that it generates the code coverage. Oops. And this is also generated locally inside the coverage directory in your project. So you can look at the code coverage as you're developing without pushing it to CodeCov. But if you do push it to CodeCov, you get nice graphs like this that show you where potential problem areas are in your code. So green means the coverage is excellent. Red means it's not so good. Yellow means it's okay. So if I'm looking at this, I can say, oh, gee, I should probably add more tests to common handler. And I can drill in on that. And I can look through the code and I can see which lines of code have coverage and which ones do not. And a great practice as developers, if you're getting started doing unit testing, is just look through here and look where there's big chunks of code that don't have any tests on it. If you're an adherent to test-driven development, the mindset that you have, it's a pretty humble mindset, but I think it's probably the correct one, is if you haven't tested code yet, it's not working. Essentially, code is guilty until proven innocent. And that's, you know, that sort of assumes that we as programmers make lots of errors, and it assumes that because we do. You make errors that are big and small, and unless you've tested the code, it's quite likely that it won't work. Now, if you run a unit test for the code, that doesn't guarantee that it'll work, but it certainly makes it a lot more likely. So a process I typically follow, I write some code, write some basic unit tests, then I start looking at the code coverage and say, where do I have big areas that I don't have any coverage? And let me try to add to that. Another nice thing that you get with CodeCov is it shows you your progress over time. So I can see I started out at 20%, that was about a month ago, worked it up to 50%, and now I'm at 65. I would like to, I shoot for typically for projects, you know, to try to be around 80%. If it's a really critical one, to get it up to 90. Much more than that, you get into diminishing returns. But it's really helpful to see this, and you want to see it progressing, and it's nice to see that progression. And you also want to make sure that it's not declining. This curve should not be going down. That means as you're adding code, you're not adding tests, you're likely to have regression errors or functional errors with the new things that you're adding, which you really want to be careful of. And just to show you real quick, so that's on the code coverage site. This is, as I mentioned, also generated locally. And so I can look at the same information here. Why should I look at CodeCub versus locally? Well, when you're in those development phases before you've pushed things to GitHub, you can be checking here to see what's happening. Doesn't look quite as pretty, but you get the same information about where you have coverage and where you don't. CodeCub, that's going to show you over time. It's also a prettier interface. I recommend taking advantage of both. So I know we went through a lot today. We've got about 5 minutes for questions. Yeah, please ask me anything about what we've gone through, any areas that need clarification, or anything else you'd like to talk about. Okay, so I see a question is, I like developing skills using Python, and I can see plenty of tools are focused on JS. I'm wondering, as a general idea, would this completely work with Python? Are you planning, for example, to port Bespoken tools to a Python package to be installed with pip? We allow you to run Python code locally, to kind of stand up a Python server locally. We have a package for that. BST Py is the name there, I believe. The unit tests, you write in YAML. So that is, you run your Python code locally, and you write unit tests in YAML, and it'll interact with that Python code. Now, the code coverage, I mean, unless you do something, will not just work with that, but you can use that to interact with Python. I can actually send you a tutorial on that. And the other things I showed you, if you're end-to-end testing, it does not matter what language you work with. Your end-to-end testing, you've deployed your skill as a Python Lambda, say. We have no insight into what the language is. With the end-to-end testing tools, it's interacting with it as a skill, just like as a user would. So it can be written in any language under the sun. And those end-to-end testing tools are going to be very useful for you. I see there's another question. Does BST proxy Lambda support any of Amazon's beta features, like the upcoming edition of geolocation event context for mobile Alexa devices? So that's a question around the proxy. The proxy absolutely does. Keep in mind, the proxy is just, it's taking a call to Alexa, which then is sent to your skill and routing it to your laptop. That's what's happening with the proxy. So any feature that Alexa supports, our proxy is going to support. And you'll see those payloads come through with additional geolocation event information. So yes, it absolutely does support that, and the proxy is a great way for testing with that, seeing those new payloads. I use the proxy all the time when it's like, hey, Amazon announced a new feature, I read the specs, what does that payload really look like? Well, the proxy, you can actually look at those payloads going back and forth and see exactly what it is. It's really helpful for that, and debugging how you handle those new payloads. It's super helpful for that as well. Using the proxy with an actual Alexa device, or using the proxy with the Alexa skill console is a great way, the skill test console is a great way to do your development. We've got about 1 minute left. I do have a hard stop at 1, so I apologize if I don't have time to answer all the questions, but really appreciate everyone joining here today. Hope this was helpful. Really appreciate everyone's participation. And like I said, we'll be sending out the replay of this as well as the slides as a follow-up. Yeah, well, thank you for joining us. We appreciate it, and hope that you find this very useful.